Namaste to all of you. In today's video lecture, we would like to discuss about the calculation of alkalinity in water. We know that the alkalinity is a particular ability of water which can neutralize the acids, free acids present. But how can we calculate the amount of alkalinity in a particular water sample? We know that we can determine this alkalinity by neutralization titration. I have discussed about the neutralization titration of a alkalinity determination for water in a separate video, so learners can go for that video also. Now before we proceed about the calculation of alkalinity in water, I have a humble request to all of you. Please subscribe my channel, press the bell icon and like and share this video. So we can calculate the alkalinity content of water by a formula which is N1V1 is equals to N2V2. Here this N1V1 is for water sample WS and here N2V2 is for acid solution. This acid solution may be of sulfuric acid or hydrochloric acid whose normality is already known. So in this formula N1V1 is equals to N2V2, these terms are their simple meanings. N1 means the normality of water sample which is to be calculated out. V1 is the volume of water sample which is also called as the pipette volume. N2 is the normality of acid solution which is already known, and V2 is the volume of acid which is added through the burette in the conical flask. That means the acid which is required to neutralize the particular alkaline species. So by this formula N1 is equals to N2V2 divided by N1 divided by V1. So we can calculate this N1, and after calculating the N1 you can find the alkalinity content is equals to normality N1 multiplied by equivalent weight of calcium carbonate. So this is N1 multiplied by 50. So you get the answer here in gram per liter. To convert this gram per liter into the milligrams per liter or parts per million, multiply N1 into 50 into 1000. So you get here the alkalinity in milligrams per liter or parts per million. So this alkalinity is calculated out by the multiplication of equivalent weight E into the normality. So if we write here this in place of this n1, we can write here the alkalinity divided by equivalent weight 50 is equals to n2 into v2 divided by v1, cross multiply here. So alkalinity is equals to 50 into n2 into v2 divided by v1 whole multiplied by 1000. So this is the formula which can you utilize for the calculation of alkalinity content of a water. Now if the particular values are known, that is 50 equivalent weight of calcium carbonate, N2 is the normality of sulfuric acid solution which is already known to us, given to us. V2 is the volume of acid used by a water sample. V1 is the volume of water sample taken into the conical flask, and 1000. If these values are known, we can calculate the alkalinity content of a water sample. Now while calculating the alkalinity content through a formula, alkalinity is equals to E, that is 50, into normality of acid into volume of acid divided by volume V1, that is volume of water sample, multiplied by 1000. So while using this formula, the value of V is very important for us. Why? Because this V gives about the 5 possible cases of presence of alkaline species in water. If only OH ion is present in water sample, then how much quantity of volume should be considered here in this case? So here volume should be P, the value of phenolphthalein endpoint, or M. If the value of phenolphthalein endpoint and methylene endpoint both are same, that means if P is equals to M, then whatever may be the value of P or M can be taken here for the calculation of alkalinity, and we can put P or M in place of this V. Case 2. If carbonate ion is present, then P is equals to half M. So in this particular case, we can write this V, we can put V as a 2P or as a whole M. That means in a titration, during a titration, if the value of M, is 5 ml and value of P is equals to 2.5 ml. Then, in this particular case, to calculate carbonate ion content, you may you may consider the value of m, that means 5 ml, or the value of p, that means 2.5 multiplied by 2. Case number 3. If bicarbonate ion is present only, then in such a case P will be 0. P is nothing. P gets failed, phenolphthalein gets failed because of the slightly acidic medium, because of the presence of bicarbonate ion only in the water sample, and this H provides a slightly acidic medium. So in such a case phenolphthalein gets failed. It does not represent the color change, but M shows a color change, and the endpoint may be of a particular value V. So in this particular case, what value should be considered for calculating the alkalinity? Which value is taken here in place of V? The answer is, in such a case, you may put the V, which is nothing but the M. In such a case, M. Suppose M is 7.0 ml, then this whole value should be taken in calculation of alkalinity. That means in place of V, we take 7.0 ml, that is the value of only methyl orange endpoint, because here P is 0. Now the case number 4. If OH ion and carbonate ion both are present simultaneously, then in such a case P is always greater than half M, and if the phenolphthalein endpoint has greater value as compared to the half value of methyl orange, it is a clear cut indication that the water sample contains OH negative ion and carbonate ion in a water sample. So in such a case, what value of acid should be taken here? The answer is, for the OH ion concentration, the value of acid V should be 2P minus M, and for carbonate ion, the value of V should be 2 into, we can write here the value of carbonate ion. For the calculation of carbonate ion, we may write here the value for the calculation of this particular carbonate ion. Here we write 2 into M minus P. So this value may be taken for calculating the particular carbonate ion present in the water sample. So 2P minus M for hydroxide ion, 2 into M minus P for calculating the carbonate ion. So this V is the volume of acid, this V is the volume of acid, and both these two volumes are consumed by the OH ion and carbonate ion. But what will be the separate value of acid which is consumed by the hydroxide and carbonate ion, which is, that is 2p minus m for OH negative ion and 2 into m minus p for carbonate ion. So these two values separately can be taken separately while calculating the alkalinity. And the fifth case, if carbonate ion and bicarbonate ion present, suppose in the water sample carbonate ion and bicarbonate ion are present simultaneously, then how much quantity of acid V should be taken while calculating the alkalinity? So in such a case, the relationship between P and M is P is less than half M. In such a case, there is always a presence of carbonate ion and bicarbonate ion in the water sample, and if for calculating, suppose for calculating carbonate ion, how much quantity of acid should be taken, that means V should be taken. So the V should be taken is equals to 2p, and how much quantity of acid will be taken by the bicarbonate ion, the acid which is coming from the burette, the volume of acid consumed by this bicarbonate ion is equals to m minus 2p. So overall, it is clear now that if the OH ion is present in the water sample, in place of V, you should take P, the value of P or M. If the carbonate ion is present, you should take in place of V 2P or complete M. In case of presence of bicarbonate ion only in the water sample, in such a case, you have only one value, which is methyl orange endpoint. So you should take this M only. Suppose in the water sample OH ion and carbonate ion both are present simultaneously. So in such a particular condition, for putting the value of V for OH ion, the value should be 2p minus m, and for calculating the carbonate ion, the value should be m into 2 into m minus p. And if the carbonate ion and bicarbonate ion both are present simultaneously, in such a case, the volume of acid V should be taken 2p for the calculating of carbonate ion and m minus 2p for calculating the bicarbonate ion. So this is all about the calculation of alkalinity in water with their 5 particular cases. Thank you very much.